Everybody, welcome back to another fun and exciting Algebra 2 class. Today we are going to be jumping into lesson and chapter number 7. Oh my goodness, that means that we are past halfway. Congratulations, you made it. Another thing that means is technically we're done with algebra. Okay, I know the class is still called Algebra 2, but all of these topics in the second half, yes, they're based in algebra, that you have to know your algebra still, but we are going to be learning all kinds of new things that are not, X and Y and moving stuff to one side and the other side and keeping things balanced. And we're going to be learning all kinds of new things, new concepts, new ideas. It's almost like, and really the Matrix chapter was kind of that way, last chapter. It's almost like they kind of just throw some things in here that they don't really know where to put in high school math. So they don't fit in algebra, they don't fit in trigonometry, they don't fit in geometry, and so boom, they all end up here in the second semester of Algebra 2. So I'm excited, and hopefully you're excited to kind of be done with the basic algebra and now on to new things, learning all kinds of different stuff. All right. I say that, and then today's lesson is basically algebra. All right, but you're going to see very quickly in chapter number 7 that it's not much algebra. It's a lot of different stuff, new stuff that you haven't seen before. All right, so let's jump down there and look at chapter number 7. That is on page 324. 324. If you look down at the screen, we're going to be talking about inverse functions today. Inverse functions. The thing that should come into your mind when I say inverse is you should think flipped. Okay, so taking one thing and flipping it or switching it for something else, and that's exactly what we do here. So we know what a function is, the function of x. We've done a chapter on that. What we're going to do here in this lesson is we're going to learn how to swap or invert the function. What does that mean? Well, we're going to take the x, which is the input, and we're going to switch it for the output. The output is the y. We also called those basically the domain and the range. Okay, I think we've talked about that a little bit. And so, yeah, we've called them also the independent and dependent variables. Okay, so the x and the y, that's what we're going to be switching. So before we can get to that, let's talk about what's called the Axis of Symmetry, and that is on the bottom of page 324. In the Axis of Symmetry, basically if I take, so let's call this line, the yellow line is going to be our function line, okay? And this pink line, this is going to be the inverse function line, okay? So the yellow one's the function, the pink one is the inverse. This purple line is going to be the axis of symmetry. So in other words, this line what it does is it reflects. All right, so the idea is almost like you have a mirror, and if you look into the mirror, it reflects something else. Have you ever noticed that when you look at your shirt? Now, of course, today I'm not wearing my shirt with my logo on it. I always have that on. But, of course, the day that I want it on, I don't have it on. But if you take something and you put it into the mirror and you look at your logo in the mirror, when it comes back to you, it's backwards. It doesn't look right. You ever try to write something and then hold it up to the mirror and it's not right? You ever try to write it backwards and see if you can make it? It's something fun to do if you haven't tried that before. But here what we're talking about is that purple line, okay, this dotted purple line that we're talking about. What that is that's reflecting, okay, the two different lines. So the purple line runs in the middle and it reflects. So the function shines down, if you will, on the purple line, and then that purple line is reflected down to the inverse. And when you put the function on the graph and you put the inverse on the graph, that's what you're going to see. You're going to see a reflection on the graph. Let me show it to you like this. Okay, I like this picture. Okay, this is a cool picture. Now, maybe you've seen this before. You've been to a lake and you've seen a mountain or some trees in the background. Well, what's going on is this is the function. Okay? This is reality up here. Okay? That's real life. That's the real mountain. That's the real trees. That's the real snow. Okay? That is reality up top. And then this down here, this area down here, I'll change the color for you and so you can see it, but this is the inverse. That's the inverse function. That's the reflection. Okay? What line is it reflecting on? This line right here is the axis of symmetry. Okay? So there's a line right there. What is that line? Well, that line is water in this case, in this picture that we're looking at. But the function is on top, reflecting down to the underneath, so that would be the inverse. So the mountain is inverted, right? So it's standing up straight in the function, but in the inverse, it's going down. And what's causing it to do that? What's causing it to do that is the reflection in the water. Hopefully that helps you understand it just a little bit more. Well, how are we going to do this? What are the steps? Put an underline right there. There we go. What are the steps to finding an inverse function? Well, I'm glad you asked because I'm here to tell you what they are. Number one, we want to replace the function of x with y. Now remember, y equals the function of x. We've learned that when we dealt with functions. So when we dealt with functions, we actually removed the y and put in the function of x. Now what we're going to be doing is we're going to be removing the function of x and replacing y back into it. You might say, why? Well, I'm glad you asked. Good question. Why? Why is always a good question in algebra, right? So why are we going to do that? The reason we're going to do that is because we're going to solve this. And it's easier to solve. Could you do it with the function of x still in there? Yes, you could. It might be a little bit more confusing. You could even do it without swapping them. You could actually just solve for x instead and then put it in there. There's a number of ways you can do this. This first step is kind of arbitrary. You can do what you want here. You can do it what works for you. What works for you might not work for me, okay? And so you figure out what works for you. Now, step two also, it kind of might work for you, might not work for you. You might want to leave it function of x, and so you're going to swap the x and the function of x. Or you might not even swap. You might come down here to step number 3 and you might say, oh, I just want to solve for x. I don't want to swap. That's fine. But at the beginning, and as I show you these, I'm going to follow these steps, okay? And I'm going to show you how to do it by following these steps. Here's the biggest thing. This one is the key right there, solving for y. In other words, we have to solve the function in order to get this to work. You can't skip this step. Now, you could call it solve for x, or you could call it solve for function of x, or whatever you want to put in there, however you want to say it. And you'll see what I mean as we go through one of these. So you're like, huh, what? What's he talking about right now? All right, be patient with me, okay? I'm just telling you some things so that when you see it, you're like, oh, okay, I get it now. Then the last thing is we are actually going to, and this is why I'm telling you, you don't need to swap those if you don't want to, is because then at the end, we swap the function of -1. And this really, I couldn't write this right. So this is really the function of -1 written like that to the x. All right. So that should be there. That -1 didn't really work out really well for me when I was typing it, but there it is. See, at the end, we substitute that back in. So do you need to substitute it? Do you need to put the y in? You do what you want to do, okay? Let's go ahead and move on to an example, and I'll show you what I mean by all this. All right. So here's our example. We have the function of x equals x cubed minus 5. Now, remember, this function of x equals y. And so I am going to go to step number 1, and I am going to replace the function of x with y. All right, let's do it. So where the function of x, we're going to put a y. So now we have y equals x cubed minus 5. Now this next step is interesting. And this example, if you want to follow this example, it is on page 326, page 326 in your book. All right, so the next step is swap the x and the y. What do I mean by that? Now, when I say that, I mean just the x and the y. Don't swap x cubed for y. It's not what we're doing, okay? We are swapping just the x for the y. All right, so in other words, we're taking this x right here and we're taking this y right here and we're switching their spots. So what we end up with is x equals y cubed minus 5. All right, so now if we look back up here, we're on to, that was step number 2 where we swap the x and the y. And now we are on to step number 3. We want to solve for y. So we want to come down here and we want to get y by itself. Okay, we want to get y by itself. How are we going to do that? Well, one way that we could do that, probably the easiest way that we could do that, is if we add 5 to both sides. And that's going to give us x plus 5 equals y cubed. Now, some of you can't handle that. Like, your brain doesn't like that at all right? Because, but Mr. Steve, we're solving for the y, so the y needs to be on the left side. That's fine. At this point, let's just take it and switch it. And so now we're going to have y cubed equals x plus 5. All I did was take that and okay, let me go back and let me show you another way to do that. Let me show you another way to accomplish the exact same thing. And some of you might like this better. So if I take my negative, my 3 cubed, and I move my 3 cubed by subtracting y cubed to both sides, that's going to cancel, and I'm going to get negative y cubed plus x equals negative 5. And then I subtract my x from both sides. All right? So now what do I have? Now I have negative y cubed equals negative x minus 5. Well, look at all those negative signs. Well, I just multiply a negative 1 through there, and what does it do? It changes all those signs, and I end up with positive x cubed plus x plus 5. Okay? Now let me show you a faster way to do that. That's a lot of steps right there to get that. So if you come back here and instead of doing that, if you will kind of follow the first logic that I was using, and you, instead of doing that, you just move the 5 over, you end up with x plus 5 equals y cubed. It's all positive. You're done. I like to keep things positive, okay? Maybe you like to be positive too. All right, well, that's the easiest way to keep things positive is by just moving the 5 over the other side. Now you can just take it and swap it around, like I said, to where you have y cubed equals x plus 5. Now, remember, my goal is to get the y by itself. So I'm going to cube both sides, cube root both sides. That is going to cancel that out, and I'm going to get y equals this. Can I solve that? I can't solve that. I just get the cube root of x plus 5. Now, believe it or not, I'm done. Okay, there is one other little step that let's do this real quick. Let's go back here. Step number 4, replace the y with the function of negative 1. So the only thing we want to do here to kind of finish out this problem is come up here and instead of the y, we're going to write the function of negative 1x equals the cube root of x plus 5. And that is my answer. That is how to invert a function. Now, you might say, "Whoa, that's really hard." It's really not. It's really not. It's just algebra. Again, I say we're done with algebra, and then I break out algebra on you. So it's just algebra. Let's do another one, and hopefully you can see this one kind of work out for you. All right. So let's do this. Same thing, we're going to follow our steps. What's the first step? Get rid of this function of x. So I'm just going to, and we're going to put a y. Okay, that's our first step. What's our next step? We want to take this y and we want to swap it out, and we're going to put it in both places that we see in x, and we're going to move the x and we're going to swap the x back out here. Now we don't take both x's over there, we would just take one x over there because we're just switching it out. So now we're going to end up with x equals 2y plus 3 over y plus 1. Now remember, what is our goal here? What are we trying to do? Well, we are trying to solve for y. Or in other words, we're trying to get y by itself. So how are we going to do this? This one's somewhat complicated, but what we need to do is we need to multiply both sides by y plus 1. What's going to happen is that's going to cancel. But if we do it to one side, we have to do it to the other side. So y plus 1 over here. So what do we end up with? We end up with y plus 1 times x. We usually write it like that when we're doing that. Equals 2y plus 3. Now again, we're kind of in a situation where it's kind of weird because now we have a y on both sides. And we don't typically see that very much when we have a y on both sides. But what we want to do here, and this is, we're just kind of following our steps, our order of operation things. We want to distribute that through there, and you'll see why in just a second. We're going to get xy plus x times 1 is x equals 2y plus 3. Now, we're making progress, believe it or not. So here is what I would do next. You can kind of do a couple different things here next. But what I want to do is I want to get this 2y over here with its other y, with its little friend. And so I would come over here and I would, let's get this over here and let's get this over here. Basically, we want to switch those two. So minus x minus x. Minus 2y minus 2y. That's what we want to do. This cancels. And this cancels. So now over here we have this. So how are we going to write this? We are going to write this xy minus 2y. We can't combine those. Why not? Because they are not like terms. They're two separate terms. We can't combine. So equals this. We'll call it 3 minus x. We could write it minus x plus 3. That's either way is fine, but we'll write it like this. Doesn't matter which way you go. Now, this is where you have to remember back to factoring, because what we have over here right now is we have a common factor in that, and this is where we get to pull the y outside. This is where we get to get y by itself. So let's pull the y outside. So we're going to have y times x minus 2 equals 3 minus x. Now, again, this is multiplication. We can't just subtract that or to get rid of it. So we have to divide this by x minus 2. Well, we divide this by x minus 2. That's going to cancel, and we're going to end up with y equals 3 minus x over x minus 2. And that would be our answer. Okay? Now, again, one more thing that we need to do to kind of finish it off is we need to replace this with the function of negative 1x equals 3 minus x over x minus 2. And there you go. There is your final answer. That is the inversion of functions. Fun, right? All right. Here, a lot of students kind of lose their mind right here because they're like, oh my goodness, what is happening? There's not really that much happening, okay? It's just algebra. It's just algebraic principles. So you have to remember back to what did we do back in algebra. And a lot of it's baby algebra principles. It's algebra 1. It's not even algebra 2 principles we're using here. It's getting x by itself and multiplying and dividing and adding and subtracting and doing all the inverse operations. The only new concept right here that I'm teaching you is this right here. Going back to this. We're replacing, we're swapping. The solve for y is the same. That's just algebra. and then the end where we replace it. The only things that I really taught you today are just swapping out things. That's all I taught you today is swapping out things. Those were the new concepts. This, number 3, you should already know how to do. That's just algebra, okay? And so pay attention there to number 1, number 2, and number 3. Swap those out, and number 4, excuse me. Number 3, just use your algebra. That you know how to do algebra, okay? So just use the algebra that you know how to do, solve for y, get y by itself, and then switch it back, replace it back to the function of -1x, okay? All right, well, that's all I have for you. I hope you learned something today. I know it was a little bit longer lesson, but there was a lot of stuff going on there. So work hard, try some of those practice problems, okay? If you missed anything, make sure you slide it back there and review that so you don't miss anything on your quizzes and tests, okay? All right, guys, we'll see you later. Bye-bye.